Ladies and gentlemen, welcome. Our Google Meet didn't work because there was too much bandwidth gone. You two have got to be quiet. So we are going to do videos. I'll try to get this pushed out, and I will try to get a time maybe from 2 to 2:30 or something like that where you can ask questions about the day's lessons. Okay? So I'll try to get that audibled for and ready for Wednesday or Thursday or Friday. But Chapter 3, Section 1. Now here's where we are starting having all the fun of everybody in and out and everything else. Nature of matter. Made up of solids, liquids, and gases. Here's examples of each. All matter is made up of atoms. They make up solids, they make up liquids, they make up gases. They are the small little things with protons and neutrons in the middle and electrons on the outside. This paragraph talks about protons and neutrons being in the middle, electrons being on the outside, and then they're all an atom together. You don't necessarily have to write this, but you need to know all things are made of atoms. Now, nature of matter, when something is made of only one thing, one type of atom, it is an element. So if we had a bunch of hydrogen here, oh, that would be elemental hydrogen, only made of hydrogen. Need to write that. An element cannot be broken down into simpler form by chemical reactions. Hydrogen is as simple as we can get. Fluorine is as simple as we can get. You can't break it down by chemical reactions even. Okay? Don't need to necessarily write this. Then, we talk about compounds and molecules. Just like atoms build together to make elements, molecules build together to make compounds. So, these are examples of compounds. They're made up of 2 or more elements in exact proportion. Hydrogen gas, or helium gas, is 2 atoms put together and then a bunch of them together to make your balloons full or to fill the air with extra oxygen, as we see with O2. H2O, 2 hydrogen, 1 water. So these are all compounds. And when we have just one molecule of that compound, that's the smallest thing. So just having one of these, this is a molecule of water. A bunch of molecules of water go together to give you your glass of water. Okay? A bunch of molecules put together gives you a compound. This molecules are the building blocks for compounds. Okay? Ions. Electrically charged atoms that are positive or negative charged. That's an ion. Positive ions have more protons. That means they lost an electron. Negative ions have more electrons. That means they gained electrons. You always stay the same number of protons. You either gain or lose electrons. Ions are electrically charged atoms, positive or negative. That's what they are. And there are ionic compounds. Remember sodium chloride. Sodium loses an electron. Chlorine gains an electron. Then they're magnetic. Or then they're electrically charged and they stick together. And you have sodium chloride. Mixtures. Mixtures can be solids. Mixtures can be liquids. Or mixtures can be gases. The thing that is important, when they come together, the individual substances retain their own properties. Still an almond, still a cashew, still a pecan, or still a M&M, still a raisin. They all keep their own stuff, but they are mixed together. Okay? So these are examples of mixtures. Mixtures are when you put things together and they keep their same properties. Air that we breathe every day, 75% nitrogen, 22% oxygen, and trace gases. That's a mixture. Kool-Aid, you put powder in, you put sugar in, you put water in. They all keep their own properties. That's a liquid mixture. Gas mixture, solid mixture. All right, that means nothing to you except telling you the pages it's on. Organic. Go ahead and shorten this. Organic compounds contain hydrogen and carbon, and they make up living things. That's all you need to do. Organic compounds contain carbon and hydrogen. They make up living things. All right, there's an example of the next thing we talk about. It's out of order. Carbohydrates are organic energy. That's what it is. Okay? Bread is an example of a carbohydrate. All right. We won't worry about writing lipids because the group that made this didn't make it correctly. All right. Proteins are made up of smaller molecules called amino acids, and they're what make up steaks. Okay? Proteins help you build your muscle and other things like that. That's what amino acids do. The final thing that we talk about here, if you've ever heard of DNA, nucleic acid are the last two in there. DNA is what's going on there. All right, we have our DNA molecule. All right, you just saw Mrs. Whalen make a cameo there. All right, nucleic acids are large organic molecules that store important coded information. All right, inorganic compounds.
Are you planning on going back to your room or to Doreen's room to do?
It doesn't matter to me.
It doesn't matter to me either.
I'm recording a video right now for them because with 24 on, our Google Meet didn't work at all in here.
Because
so.
of me?
Yeah, but that's fine. We'll record videos and I'll meet with them at a different time. So inorganic compounds. Inorganic compounds are made of elements other than carbon. Things like your desk, things like rocks, things like cardboard, or things like metals. Those are all inorganic. All right. Now there is an importance of water. All living things need water to survive. Our bodies are made of at least 50% water. Many people will say much more. All the chemical reactions in our body take place in water. All right? Remember, if I went too fast, pause or rewatch, and you can go back and take care of these different things. I will try to get this posted soon. All right, goodbye.